Anthropic just shared a truly staggering software engineering project.
Yeah, the sheer scale completely blew my mind today.
They migrated the entire Bun runtime from Zig to Rust.
That is a massive framework translation.
It produced about 750,000 lines of code.
Functional code, too.
Yeah.
And in just 11 days.
Right. It achieved a 99.8% test pass rate.
Which is astounding for a code base that huge.
But human engineers didn't actually write this code.
No, they didn't. AI agents did it.
And they worked entirely in strict parallel. Intro music. Welcome to the deep dive.
It's great to be here.
Today, we are unpacking Claude Code Dynamic Workflows.
It's a fascinating look at the future of digital labor.
We really need to look under the hood carefully.
We have some incredibly dense source material to explore.
Here is our roadmap for the discussion today.
First, we're going to explore what these workflows actually are.
Then we'll see how they differ from familiar Claude features.
You might already be using some of those handy features.
After that, we'll discuss the massive hidden token cost trap.
You definitely need to avoid that expensive pitfall.
Finally, we will show you how to launch one safely.
Step by step, so you don't blow your entire budget.
AI is moving far beyond simply answering our basic questions.
Yeah, it's now managing massive, complex software development projects automatically.
So let's just jump right into it.
Sounds good.
We already know that AI can write code.
Right, we've seen that for a while now.
But writing 750,000 lines is totally different.
It requires a completely different processing architecture.
We have to look at how it orchestrates these tasks.
Because a normal chat session simply cannot handle that workload.
The context window would just break immediately.
Exactly. Dynamic workflows are designed specifically for these massive tasks.
Things like code-base-wide bug hunts.
Or comprehensive security audits across a whole system architecture.
Tasks that are just too large for a normal session.
I like to use a specific analogy for this.
Oh yeah, let's hear it.
Think about running a massive construction site.
Okay, a construction site.
Claude acts like your general contractor in this scenario.
Right, the person overseeing the entire build.
Exactly. It doesn't try to build the huge house alone.
That would take way too long.
Instead, Claude looks at your initial project prompt very carefully.
It reads your requirements.
Yeah. Then it creates a detailed blueprint.
The source material calls this the orchestration script.
Right. Then it breaks the task into much smaller parts.
Like framing a single room or running the plumbing.
Precisely. It basically hires specialized task workers for the job.
So, different AI subagents handle the framing and the plumbing.
And they execute their assigned components in strict parallel.
They don't wait for each other to finish.
Then it brings in the strict city inspectors.
Ah, I see. The verification workers.
Yeah. They check the work, then it hands you the keys.
The keys being the final answer you receive.
Everything runs completely automatically once you approve it.
Let me make sure I have this process flow correct.
Go for it.
You give it a prompt. That prompt generates a workflow script.
Right. The blueprint.
Then, task workers execute their specific parts.
Simultaneously, yes.
Then, verification workers review it.
Exactly.
And finally, it produces the final answer.
You nailed it.
What triggers the verification workers to step in?
The workflow script defines specific checkpoints for mandatory review.
So reviewers check the work before moving to the next stage.
Right. And this ensures absolute quality across the massive code base.
You can't have hallucinated code breaking the entire migration project.
It acts as an automated quality gate.
2-sec silence. Understanding this sheer scale raises a very important question.
Which is?
Why do we actually need a brand new feature today?
That's a very logical question to ask right now.
Couldn't we just use the AI tools we already have?
The source material breaks down these specific differences carefully.
Let's unpack that. What about standard AI skills?
Well, skills provide a reliable, repeatable process for the AI.
They use reusable instructions for very consistent daily tasks.
Right. You might use a skill for standard code formatting.
Or for generating weekly release notes.
But workflows manage the execution of much larger processes.
So skills are just a repeatable process.
Yeah, for a single worker, workflows manage the whole crew.
Okay, what about subagents?
Subagents are really good for a few separate side tasks.
Like asking an agent to check an API key.
Right. Workflows coordinate many related tasks together at once.
They handle a much larger scope of work overall.
Exactly.
Wait, I want to push back on something here.
Sure, go ahead.
Isn't an agent team basically the exact same thing?
How do you mean?
Well, it's just multiple AI minds working together on something.
It sounds similar, but the focus is totally different.
Okay, break that down for me.
Agent teams focus heavily on collaboration and different viewpoints.
So they debate the best path forward.
Yeah. They share complex information to solve a problem collaboratively.
But dynamic workflows don't do that.
No. Workflows focus purely on strict coordination and rapid execution.
They divide and conquer in strict parallel paths.
Exactly.
Yeah.
They aren't debating philosophy, they just execute the plan.
So teams are for collaboration, workflows are for coordination.
You got it perfectly.
What about the /goal command feature?
The /goal command loops continuously until a condition is met.
It focuses strictly on reaching one very specific outcome.
Like fixing a difficult bug through trial and error.
Workflows don't loop endlessly like that.
No, they execute a specific parallel plan across independent parts.
Can a workflow use a skill?
Yes, individual workers use them during their assigned tasks.
Yes, individual workers can use skills for specific instructions.
It creates a very powerful combination of different AI tools.
It leverages everything Claude knows how to do simultaneously.
That's why it's so incredibly effective.
Now we've isolated the core differentiator of this new feature.
It's all about parallel execution at a massive scale.
We should probably define parallel execution quickly.
Good idea.
It means running multiple independent tasks at the exact same time.
Right. It removes the bottleneck of sequential processing entirely.
Traditional AI works step by step in a straight line.
But workflows expand a task into multiple simultaneous paths.
Let's look at what that actually looks like in practice.
When is it actually worth your time to use this?
Yeah, when should I spin up a dynamic workflow?
They provide the most value for very large divisible tasks.
The project must be easily broken into standalone parts.
Exactly. Large code-based reviews are a perfect use case here.
You might need to review hundreds of files across modules.
Claude can analyze multiple modules at the exact same time.
Then it combines all those findings into a single report.
It's incredibly efficient.
Skill audits are another really great example from the source.
Yeah, that's a very practical application for developers.
You might need to evaluate many skills using identical criteria.
Each skill gets reviewed completely independently by different workers.
Then the system combines the results perfectly.
It keeps your AI tools sharp and optimized.
Multi-part research tasks fit this parallel model perfectly well, too.
You can have agents scouring different databases simultaneously.
One checks API docs, while another checks legacy code bases.
Then they combine their findings into a cohesive report.
Beat. Let's bring back that bun migration example from earlier.
Right. Zig to Rust.
This involved huge framework and language syntax changes.
It required hundreds of agents running entirely in strict parallel.
Whoa. Imagine scaling to hundreds of agents working simultaneously.
It completely changes how we think about manual tech labor.
Framework migrations usually require massive amounts of human engineering effort.
API upgrades normally take weeks of tedious manual review.
Imagine manually rewriting every single API call in a project.
Humans get tired, they make typos, they lose focus easily.
But the AI agents maintain perfect consistency across hundreds of files.
And they tackle the boring parts of software engineering instantly.
Why are file migrations a perfect fit for this?
Because Claude can analyze different directories without getting confused.
Because Claude can analyze multiple affected areas all at the same time.
It saves countless hours of painful, repetitive manual code checking.
It frees human engineers to focus on high-level system design. Mid-roll sponsor read. Seeing hundreds of agents spin up is undeniably thrilling today.
It really is.
But this brings us to the dark side of this feature.
We definitely need to discuss the hidden token cost here.
It is a very serious consideration for anyone using this.
This is the biggest risk with dynamic workflows by far.
They can consume substantially more tokens than a normal coding session.
Anthropic specifically warns users about this massive potential burn rate.
It can get incredibly expensive if you aren't paying attention.
We should quickly define token usage for clarity here.
It's the cost units AI uses to read and write text.
Exactly. That's how you get billed.
Why does token usage explode so rapidly with these workflows?
Well, a normal chat session uses one main context window.
You just chat back and forth on a single thread.
Right. But workflows are very different structurally behind the scenes.
Map so.
Multiple workers need access to the exact same initial instructions.
Oh, I see.
They all need the same files and overarching project context.
Beat, so the same context gets sent over and over again.
Yes. Dozens of workers mean massive token burn across the board.
Even if the final output report is completely short.
Yes, because each worker performs its own independent, isolated analysis.
Each one needs full system context to do its job.
If 50 agents need a 10,000 token file, that multiplies fast.
It's like paying 50 people to read the same massive book.
And every single worker reads Chapter 1 before starting work.
Wow.
If your initial context window is 50,000 tokens long, and you spin up 20 different parallel task workers simultaneously,
You just consumed 1 million tokens just setting up the board.
exactly, the math gets incredibly scary very quickly.
So how do we avoid this massive token waste?
The solution is defining a very narrow, specific scope.
I still wrestle with prompt drift myself, honestly.
It's a common struggle.
Defining a hyper-exact scope is surprisingly difficult to do well.
It's difficult, but it's absolutely essential for dynamic workflows today.
You must define the exact objective clearly before starting anything.
You must isolate the exact files or folders involved initially.
You must declare the expected output format very precisely too.
You can't just ask Claude to, fix your app.
A smaller scope helps Claude create a much more focused workflow,
It prevents the AI from exploring completely irrelevant code paths.
which saves your valuable tokens in the end.
A well-defined workflow uses far fewer tokens than broad requests.
Always ask if you really need massive parallel execution first.
Sometimes a simpler feature solves the problem much cheaper anyway.
Does Claude warn you before spending all those tokens?
Thankfully, yes. It shows a clear confirmation screen first.
Yes, Claude always shows a confirmation screen before the workflow actually starts.
It estimates the complexity and asks for your explicit permission.
That's a very thoughtful design choice by the Anthropic team.
It ensures you never spend tokens completely by accident.
We know the massive token burn risks involved with this now.
Right?
How do we practically put our hands on the keyboard?
You want to know how to trigger one safely.
Yeah. How do we do this without blowing our budget?
First, you don't write the workflow scripts yourself manually.
Claude builds the entire workflow automatically for you.
It bases everything on your clear initial project description prompt.
You just tell it exactly what you want to achieve.
Let's walk through a concrete example from the source material.
Okay, what's the scenario?
We want to audit a library of local Claude skills.
Those are usually stored in the .claude/skills directory.
Exactly. Step 1 is defining the strict project scope first.
I can tell Claude to identify duplicated instructions across files.
Or you might ask it to find outdated guidance there.
And I must ask for a report with specific actionable recommendations.
Right. Step 2 is letting Claude build the workflow automatically.
So Claude handles all that complex orchestration behind the scenes.
You don't design the execution process manually at all here.
It breaks the task apart and assigns the virtual workers.
It writes the orchestration script based on your initial prompt.
Step 3 is reviewing the execution plan carefully before proceeding.
You really need to check this before you click approve.
Right, and this prevents a surprising amount of wasted token usage.
You can see exactly what files the agents plan to read.
Make sure it isn't analyzing more than strictly necessary.
If it wants to read your node modules folder, stop it immediately.
Step 4 is reviewing the final comprehensive report it generates.
This is honestly the true beauty of the entire system.
It shows affected files, supporting evidence, and specific recommended fixes.
The workflow synthesizes all those parallel findings into one document.
Without this, you'd be opening and reviewing every single skill file manually.
It highlights exactly what needs to change in your code base.
Step 5 is saving good workflows for future repetitive use.
Right. You don't want to recreate the wheel every time.
Can I reuse a workflow once it's built?
Absolutely. You just save it for the next time.
Absolutely. Just save it to your local Claude Workflows folder for next time.
You don't have to generate the orchestration script from scratch.
So you basically build a personal library of reusable processes.
It standardizes how you audit your code across the board.
2-sec silence. Let's zoom out from these tactical steps for a minute.
Good idea.
We need to understand the underlying philosophy of the source material.
The golden rule is choosing the right feature for the job.
You don't always need the most advanced tool available today.
That is the core message we want to convey today.
Use standard Claude code for quick, simple, daily coding tasks.
Use standard skills when you have repeated, consistent, automated tasks.
Use Subagents when you have minor supportive side tasks.
Use Agent Teams for collaborative, multi-viewpoint problem-solving sessions.
Use the /goal command for iterative, condition-based loop tasks.
And save dynamic workflows for large, truly independent parallel tasks.
Dynamic workflows only make sense with massive parallel execution architectures.
If tasks must happen sequentially, do not use a dynamic workflow.
If step B requires step A to finish, Avoid workflows entirely.
Match the AI tool directly to your specific problem shape.
It saves time, saves money, and produces much better results.
It's all about working smarter, not harder.
If AI can orchestrate hundreds of parallel agents successfully today, if it can port entire massive code bases in 11 days,
with 99.8% accuracy, no less.
what does the future of a one-person tech startup look like?
It looks completely different than it did just last year.
Perhaps your primary job is no longer writing code manually.
You transition from a manual coder to a general contractor.
Perhaps your job is simply defining tight scopes for your AI workforce.
You manage the grand vision while the AI swings the hammers.
I want you to audit your repetitive tasks this week.
Look closely at your daily work.
Ask yourself, could this task be broken into parallel, independent parts?
Think about how you construct your daily blueprints going forward.
Thank you for joining this deep dive together with us today.
It's been a great conversation.
Take care and keep exploring the possibilities safely out there. OTRO Music.